video, we will going to take up uh, a how to analyze a design, a 4-bar linkage, and analyze the Grashoff condition, and to prove that is class 1, class 2, and class 3. So to do that, so what is the Grashoff analysis equation, which is S plus L should be less than or equal to P plus Q. So this is the condition. So the condition can be broken this into two parts. One is S plus L less than P plus Q, and two, S plus L is equal to P plus Q. What is S? S is nothing but the shortest link, and L is the longest link. P is the other link, and Q is one more other link. So to do that, so here the first condition, let us take S plus L is less than P plus Q. In this condition, consider the first case when the shortest link adjacent to the fixed link is fixed. So we have to assume some data here. So we have taken the length of the shortest link as 30 mm, the length of the longest link as 80 mm, and other link as 60 mm, and the another link, which is the remaining link, will be Q is equal to 70. So the condition says S plus L, that is S is equal to 30, L is equal to 80. So 30 plus 80 becomes 110. P plus Q is P is equal to 60 and Q is equal to 70. So P plus Q becomes 130. So 110 is less than 130. So the condition is satisfied. So this satisfies the condition of Grashoff equation. So there is one more. This mechanism is called the crank rocker mechanism. In the case 2, when the shortest link is fixed link, then in that case it will be having double crank mechanism. And in case 3, the shortest link is opposite to the fixed link. If this is considered, then it will be double rocker mechanism. So we will going to analyze this. So what the conditions, what it says, we need to satisfy these conditions. We have to analyze these conditions. So to satisfy these conditions, how to satisfy these conditions, we need to analyze this by using the Fusion software. So here, I am assuming the thickness of the link as 2 mm. So to do that, first I will go for the Fusion software. So in this, so here I will go to the part design and make it as a hybrid and say convert. Now first we will going to create first link. So which is the first link? The first link what I am considering is S is equal to 30. So I will go for sketch, click on this front view. Now I will go to create, then go to slot, take the center to center slot. You select this and you place this here. Then give this distance as some radius. Then go to dimension, click on this dimension and give the distance as 30. Okay. Now I think this is going to be constrained automatically. I will take the midpoint of this to the center of this. Yes. Once you do that, now we have this radius as, I'll go to dimension, click on this dimension and take the radius as 10. Then I will going to take the circle of diameter 10. I will go for two circles having some radius and I will go for dimension and go to constraint, select equal, select between these two. Then I will go for dimension, take the diameter as 10. Okay. Then go to constraint, go to concentric, select this circle with this semicircle. Similarly with this circle with this semicircle. Now I will going to switch off the constraints, disable the constraint. Now we will see, I will move this and place it appropriately so that when you want to do the model, you should be able to clearly see the dimensions. Once you do that, now once you create this profile link, I will go for the finish sketch and then I go for extrude. I will take on this profile and give the dimension as the thickness of the link as 2 mm. I am assuming that value. So we have created this particular link. So since I want to engrave the uh, link as S, because that is the one what we have shown here, S is equal to 30. So to do that, I will go for offset plane, click on this plane and take the dimension as 0.2. I'm just taking 0.2 mm. If you go to the right view, you can see that this is the gap what we have. This is the surface of the model and this is the plane which we have created. I will go back to 3 dimension and go to sketch, click on the offsetted plane, and now you go to create and come down to text, okay, and click on OK. Now here you take some window and then take the uh, font as Times New Roman, take the Times New Roman and take the height as, we will take it as 5 mm and give the sample text as yes, that is the engraving position, okay. Yes is the one which we are, that is the smallest link which we say yes, and I will say okay. Then I will try to move this, go to create, go to move, go to modify, sorry, click on, uh, okay, click on finish sketch. Now you go to create, go to move, select this, move this, okay, sorry. Now you go to here, you just go to modify, click on move, move the sketch objects, you select this one, okay, select this and you place it wherever you want. I will just go to the front view and you take nearer to this, and this is only for your reference that what we can do. I will just go to OK. Then I will go to 3 dimension and go to create, go to emboss, select this profile, okay. Then select these faces as this, okay. Then the depth of the engraving is 0.2, okay, and say click on OK. Now we have the link what we have created as the shortest link. Then I need to save them and I'll go for appearance and go to paint, okay, put on glossy and take the whichever the one which you want. I will take white and say close. So now I'm going to save this. Since I'm in this Grashoff mechanism, I will just click on save and go to link S, link yes, and say save. So this is the first component which I have created, the link S, because that is the smallest link. Now we will go to the next link. Repeat the same procedure for all other links. So to do that, I will just come down, remove this. Again, I will go to the second link, L is equal to 80 mm. So to do that, I will go for part design, then come down to hybrid and say convert. Then I will go for a sketch, okay. Click on this particular sketch, or sorry, front view, then go to create, then go to slot, center to center slot, select this, and I will going to select this portion and take this height. So go to dimension, select this dimension as 80, okay, and take this radius as 5, okay, radius as 5. Sorry, I will going to take this as radius as 10, 10, okay. Now I want to go to the constraint, take the midpoint of this onto this one. So now we have placed everything. Then I want to go for circle. We'll go for circle, select the circle, and similarly you draw one more circle. And go to constraint, select equal, select between these two. Okay. Then you go for dimension, give the dimension as diameter 10. Okay. Then I will go for constraint, go to concentric, select this with reference to this. Similarly, you select this with reference to this. And now you remove constraints. Now I will move this and place it here. Then you take this here. So once you have the model created, go to finish sketch and go to extrude. Click on this profile and give the dimension as 2 mm. So we have created this second link. Then similarly, go to construct, select this offset plane, select this and give it as 0.2. Once you do that, now you go for sketch, click on this sketch. Now you come down to create, go to text, click on OK and take this here and type longest link is L, type L, and then thickness is all of the things are going to remain the same. Okay, go to modify, move or copy, select this and you drag this and place it here. Okay, approximately at the center, and then go to finish sketch. Sorry, you go to OK, then you go to finish sketch and go to 3D, and now go to create, go to emboss, click on this sketch profile and then go to faces, click on face and take the 0.2 mm depth and say OK. Now we want to save this. I will go for appearance, then come down to green. I will select this green and I will click on OK. So once you do that, now I will go for saving this. You click on save and then go to link L. Link, that is the longest link what I'm talking about. Then click on save. Now once you do that, you will going to get the link L, which is the second link which has been modeled now. Now the next portion is I will go for the third one, which is the third one, link P, which is 60 mm. So to do that, I will go for again, go to sketch, click on the front profile, then you go to create, go to click on slot, take the center to center slot, select this point and drag this and go to dimension. So P is equal to 60 now. Dimension, take this dimension as 60. Then you go to constraint, select on midpoint, mid of this line to be at the center, and then give the dimension of this. Sorry, go to dimension, select this and give the radius as 10. Once you do that, go to finish sketch. Then, again, you just go back, edit sketch, go to circle. Then you create these two circle and go to constraints, select equal between these two. Then go to dimension, take this as 10, diameter 10, and then go to constraint, select concentric, select between these two, and similarly you select between these two. Then you go to constraints, disable constraints. Now you just go to select and you keep it here. Similarly on this side you keep it here and on this side. So this is how you will be able to constrain dimensionally as well as on the geometrically constraints. Once you do that, now we will go for finish sketch and go to extrude, click on this and give the dimension as 2 mm and give new body as say okay. Once you do that, now you go to offset plane, click on this plane, give the dimension as 0.2, okay. Click on sketch, click on this profile or the offsetted plane, then click on create, click on text, then click on OK. Then you take this window, then give the this as the other link P, capital P. Then you click on OK. Then go to modify, click on move, select this text and take this here and you place it here. Okay. And you place it at the center. Then click on OK. Then you go to finish sketch. Then go to 3D. Then go to create. Click on emboss. Sketch as this. Then go to faces. Click on this face and give the depth of embossing as 0.2 and click on OK. Now, once you do that, now this is how we will be able to create the link P. So now I will go for appearance. Now again come down here, take this as the red and click on this and say OK. Yes. The next link is I want to save this particular link. Just click on save and say link P. Okay, link P and save it. Then we will go for the next one, link Q down. So to do that, again, I will exit this. So once you exit, now we want to go for the one more model, that is the link Q. So to do that, I will go for sketch, click on this profile, that is the front view or the front plane, and go to create, click on slot, then go to center slot. You can take it here itself and you take it outside and you bring it here. Go to dimension, select this dimension, give the dimension as 70. Then you go to constraint, select on midpoint of this line with reference to this. Then go to dimension, click on this, give the radius as 10 and then go to circle, select these two circles, then go to constraint, select equal between this and this, then go to dimension, select this and give the diameter as 10, then go to constraint, select concentric between this with reference to this and this circle with reference to this semicircle. Now you go to constraints, disable this constraint and then go to select and place it nearer to and diameter 10 here and similarly we have the radius 10 here. So once you create this profile, then go to finish sketch and then go to extrude, click on this profile and give the dimension as 2 mm and it is on your body and say OK. So now I want to create the embossing. To do this, I want to have 0.2 mm embossing. So I'll go for an offset plane, select on the front surface of the model and give that, since it is along the dimension of the arrowhead, you give positive 0.2 mm. So when you go to the 3 dimension again, you can see that there is a gap of 0.2 mm from this face to the offset plane and then go to 3 dimension and go to sketch, click on this and you take the create, go to text and you click on OK and you take this window and type the link as Q, that is I'm embossing that click on OK, then go to modify, move, select this, and you take it approximately to the center of the profile and say OK. Then go to finish sketch, and similarly go to create, click on emboss, select on this profile with reference to these faces as this, and give the dimension as 0.2. Now we go for appearance. Now we come down to this and click on this and say close. So once you do that, now I'm going to save this model. Now I'll go for link Q now. Okay. So these are all the models which I want to create. Once I create this, now we want to satisfy these conditions. So what I have done is the case 1, S, L, P and Q we have taken. Now I want to assemble this. So to do that, so here I will just come out of this. Now what he says, yes, shortest link adjacent to the fixed link. I will take, say, I can take either P or Q, whichever you want, you can take. Shortest link should be adjacent to the fixed link. That is what the meaning. So, for example, if I take P as my reference, the first thing is I will take P and place it here. I will drag this. Okay. I will go to the part design, go to part and make it hybrid and say convert. Now we will go for Q or P. I will drag this P and place it here. This is the first link which I am considering on to be, which is the fixed link. So that is the one what I am considering for the shortest link P. Shortest link adjacent to the fixed link is the one which I am considering. So I will take link P. So I will click on OK. So you can see that link P is automatically grounded. Now, if I try to move this, it is not possible to move because it is already grounded here. You can see there is a symbol here that shows that it is grounded. Next, I will going to take link S now. The first link which I will going to consider is the smallest link. So I will consider here. So the moment when I drag this link onto this assembly, it always goes to the center. That is basically because we have modeled with reference to the origin. So that is the reason why it has been considering. And now the one what it has been shown, if you see here, I can rotate this link or I can do whatever the things which you want. Okay, and I can rotate about this point like this. So these are all the 6 degrees of freedom, whatever we have. So similarly, I can move this wherever you want. So now what I want is I want to make this angle as 0. So here, so I will just cancel this and I will go back. Now I want to move this. I will just click on select and you move this, select on this and you move it. So this has got all 6 degrees of freedom. Now I want to arrest the 6 degrees of freedom. So I will go for joint and click on this particular center point of this hole with reference to the center point of this hole. Okay, center point of this. Now we can see it has been rotating. The first time when you are doing it, it will be always, it will be in this condition, which is rigid. Okay. Now this is the position where it is going to be get assembled. Then since I want the rotation, I will go for the revolution joint. So it will going to be rotated about that particular axis. So once you do that, you click on OK, then you come down to the 3 dimension. Now, as you see, I can rotate this. This one I can rotate by 360 degree. Okay. So that is the shortest link. Shortest link adjacent to the fixed is this. Now the next link what I want is link Q. I will take this Q and I will take this Q and I will keep it here. Then again it goes to the center. You drag this and place it outside. Now I will click on OK. Then go to joint. So how to get into the joint? Go to assemble, click on joint, or the shortest key is J. Click on this. And what I want is I want this position of this center point should be aligned with the center point of this now. Okay, click on this now. Now it has been rotating here by 360 degrees. That is, again, it is a revolution joint. So you just click on this, it will be keep on revoluting with reference to that point. Okay. Now I'll go to click on OK and go to 3 dimension. So one position is this, okay, and the other position is this. Okay. Now what I want is I want P SQ. Then I will take link L now. You just take the link L. Again, it will place at the center. Then again, you drag this and keep it here. So now I will click on OK. Then I will go for assemble, click on joint, select on this center point of this link with reference to the center point of this link now. Okay. Now it will be revoluting with reference to this point. Similarly, if you see that is from the side view, you can see that it will be on this side of this link. Okay. So again, I want to go for joint. I will use the shortcut key as J and take this the center point of this, and with reference to take the cursor on this surface, automatically it gives the all snapping points. The snapping point of this I need to consider. You just take the cursor onto that snapping point on that side of the surface and you click. The moment when you do that, you can see that this link is also being getting rotated. I will click on OK. So now we have all these links have been fixed now. Now, if I go to select and if I try to rotate this link, see what happens. See here, it is rotating and the other is the oscillating. So this is called crank rocker mechanism. So we have this crank rocker mechanism. So now how to animate this? So you just go to relationship, enlarge this, or just go to revolute, right click on that revolute one and make this animate joint relationship. Now you can see that here this has been operating here in such a way that the crank S, the link S is rotating by an angle of 360 degree, whereas the corresponding link Q is oscillating. If you look from the front view, you can see link S is rotating by 360 degree, whereas link Q is oscillating with reference to the other end of the link P. Link P is being fixed. So if I don't want to see the relationship, you just disable this. This is the one which is being rotating by an angle of 360 degree. So, whereas Q, the link Q is oscillating. Since this link S is rotating by an angle of 360 degree, so that is why it is called as a crank. And link Q is oscillating with reference to this point, link other end point of the link P. So it is, since it is oscillating, it is called as a rocker. So that is the reason why it is called crank rocker mechanism. So next we will going to consider the case 2. Shortest link is fixed. Once we say the shortest link is fixed, that means you will going to have double crank mechanism. So we will going to analyze this. So to do that, I will just press escape. Now I will not going to change the model now. Instead of changing the model, what I will do, I will come down to this. You cannot have two links grounding. So only one link has to be grounded. So which is now what he wants in the second case is the shortest link is fixed link. So to do that, that means the link is to be fixed. So what we need to do is you go to the link P and right click on link P and first you make that unground from parent. Now the link P is been removed. Now I want link S to be fixed because that is the shortest link. You just right click on that link S and make that as the ground to parent. And then existing assembly relationship ground to parent you do. So now the link S is fixed. Now again, you go back to the relationship, come down to revolute and right click on the revolute joint and go to click on animate joint relationships. Now you can see once the link is fixed, both link P and link L both are rotating by an angle of 360 degree. So, whereas Q will not be rotating by an angle of 360 degree. So, therefore, it is called double crank mechanism. When the shortest link is fixed, you will going to get the double crank mechanism. How do I say that the double crank mechanism? Both link P and link L will be rotating by an angle of 360 degree. So that is the reason why we say both link P and link L are by rotating by an angle of 360 degree. Therefore, it is called double crank mechanism. Then we have the one more uh, uh, case wherein shortest link is opposite to the fixed link. So what does it mean? Which is the shortest link? Shortest link is opposite to the adjacent fixed link. Shortest link is opposite to the fixed link means what? The shortest link opposite is the one which is Q. So if I just rotate this, you can see this is the shortest link. Opposite is link Q. So I want link Q to be fixed now. So what I will do, I will just right click on link S, unground from parent. Then you come down to link Q, right click and make that as the ground to parent and say ground to parent. Now we have this link Q is fixed. Once the link Q is fixed, shortest link is opposite to the fixed link. So the link Q is fixed. Opposite to this link Q, fixed link is S. Now I will just go to again revolute, right click and go to animate joint relationship. Now you can see both L and P are oscillating with reference to the one end of Q and the other end of the link Q. So since both are oscillating, it is called double crank mechanism. Sorry, double rocker mechanism. So you can see here, it is the double rocker mechanism. So this is how we will be able to analyze the conditions of Grashoff mechanism. So in summary, when the shortest link adjacent to the fixed link is there, you will going to get a crank rocker mechanism. When the shortest link is fixed, you will going to get double crank mechanism. And in the shortest link is opposite to the fixed link, you will going to get the double rocker mechanism. This is how the first condition of the Grashoff mechanism, that is S plus L is less than P plus Q, the condition is satisfied. Thank you.